Hi, my name is Stuart Lynch, and this is the second video in the SwiftData series. In the first video, we took a look at the basic CRUD functions of SwiftData and how the data is stored in a model container in your device. Well, in this video, we're going to take a closer look at that model container and how we can configure it to meet our own needs. In addition, I'm also going to show you how you can create mock data and have it stored in memory so that you can use it in your previews. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. In that last video, we were able to persist our data to the application support directory, and when we ran our app, we printed out the path to that URL in our console. If you completed the project from that first video, you can continue along with me. If not, you can download the completed project from the link in the description, and it's a GitHub repository listed in that description. By the time you watch this video, there may be more branches, but you want to make sure that you start with the one that ends in the first video _CRUD. When you're at this page, you should see the completed branch from the video has been selected. You can download it as a zip or choose to do as I do and use the GitHub CLI. I recommend that you do some investigation on this command line interface, but that's for another day. So where we left off, we found out that when we ran our app in the simulator and had it print out the location for the persistent SQL database, the default location is the applications library application support directory for the selected simulator, and the database is named default.store. And this will be the case for every SwiftData project that you create. Often you may store data like images in the documents directory for your apps. Well, you can have your SQLite database stored there as well and use a different name. This is your choice. The default is used because we use the model container for and specified our model method. By option clicking on the method, we can get more information. There's an in-memory option that we used in our preview so that the data is kept in memory only, but of course we don't want that for the default in our application. Autosaving is enabled by default, so that's why we never had to specify a call to a save method when we created, updated, or deleted our books. I'm not going to get into this is undo enabled or the onSetup callback in this series, but I encourage you to dig down and look through the documentation on your own. Further down, we're told that the environment model context property will be assigned a new context associated with the container. Remember, we used that when we had to update and delete our... Remember, we used that when we created with an insert or deleted one of our objects. All implicit model context operations in the scene, such as the query properties, use this environment's context. It's the context that has our insert and delete methods and handles the autosave. By default, the container stores its model data persistently on disk, just as we learned. The container will only be created once, however. So each time we launch our app, we're not going to create a new container. New values that are passed to the model type and in-memory parameters after the view is first created will be ignored. If you want more control, we'll need to use a different overload for creating the container. And if you drill down into the documentation, we'll see that there's actually other choices. Specifically, one where we can pass in a model context, and another where we can pass in a model container instead of a persistent model or an array of persistent models. It's this option that I want to explore a bit more. So let me drill down on model container and see that it refers to such things as model configuration, schemas, and schema migration plan, and we'll get to that later on in the series. But there are three things that you need to be aware of. The model container is responsible for creating and managing the actual database file, used in all SwiftData stores needs. And as mentioned above, this gets created once. The model context has the job of tracking all objects that have been created, modified, and deleted in memory, so that they can all be saved to the model container at some later point. So when we create our model container, the context is available from the environment. The model configuration determines how and where the data is stored, including which CloudKit container to use, if any, and whether saving should be enabled or not. This configuration is provided to your model container to determine how it behaves. So we need to explore this configuration option a bit more. In the location where our app launches, where the app main declaration is, let's create a new container property that's going to allow us to configure the name and where we want to store our database. First, we'll create a container property that is a model container, and in our initializer, where I currently print out the directory to the existing data store, I can configure that container. Well, we can create a configuration, which is a model configuration. It has a number of different overloads with properties, many of which are optional or have default values. One just has a URL property that will allow us to determine where we want to store the container and its name. It allows us to specify a different directory, and when we append a path, that will allow us to name our data store to be whatever we want. So let's set the location to the documents directory, and we can give it a name other than default.store by appending a path and specifying our own name, like mybooks.store. Next, I can now create a new container and assign it to my container property. The overload I want to use is where we pass in our persistent model types as a variadic parameter, along with any configurations I might have. And in our case, we have one of each, so we can just pass in book.self and config. When I create my model container using the model container with configurations, it can throw. So we have to use a try, and we have to enclose this in a do catch block. In the case that it would fail, your app's not going to run anyway, so I'm just going to use a fatal error and display a string could not configure the container. Now, instead of using the model container for our persistent model mentioned here, I'll use the model container method that just asks for the container, which we now have. And instead of printing out our path to the application support directory, let me print out the path to the documents directory. And I don't need percent encoding here because it's not necessary. There are no spaces in that path. If we run this now, our app launches, but we see that whatever data we had before has been lost because we're no longer using that other container. So let's open up the path. And here we see it with our new name. It's being stored in the documents directory. That old container in the library's application support directory is still there though. I personally don't like to move things into the documents directory, so I'm going to go back to the application support directory and use a different overload to do this and change the name. So I'm going to comment out the body of that new initializer now, and I'm going to create a different container. We'll get into migrations later on and you'll learn about schemas. But a schema is an object that maps model classes to data in the model store. And that helps with migration of the data between releases. But for us, all we need to do is specify an array of the models that we have, and we have only one. So we can say let schema equals schema, and the array contains the book.self. Well, now I can create a configuration that uses the schema, and I can provide a name as the first argument for our data store, followed by the schema, which is what we've just defined. Now there are plenty of different options here, but all I need is the one to specify the name and schema, which we can do. Then, as before, we create our container in a do catch block by trying to use the model container's overload for the schema, this time with the configuration, the single config. And again, we'll catch the error. Let's comment out that documents directory path now and uncomment the print for the application support directory path and run once more. When I return to the application support directory, I see that we now have added that new name container, and we still have that old one, the default one. And I encourage you to read through the documentation so that you can create your own containers as you wish. I'm going to leave it with this last option now, but I'm going to go and delete the container from the documents directory because we're no longer accessing it. And remember, by creating a new container with a different name in the application support directory, we lost all the data from our last lesson. It's still in that default location. Well, if we delete the My Books, but rename default as My Books, we should then be able to recover all of our data. So let's do that. And let's run our app. Great, our data's back. So rather than running in the simulator, I'd like to be able to use mock data that I can have just for my previews. And this will only be used for our previews, so in Xcode, with the preview content folder, I'm going to create a new Swift file, and I'm going to call it book samples. And inside there, I'm going to create an extension to our book model, where I can create a static property representing an array of books. So I'm going to create that static property, and I'm going to call it sample books, which, as I said, is an array of book. So we'll start with an empty array. Now within here, that's where I want to create a variety of different book samples. Now because there are so many different default values and optionals, there are many different constructors for creating a sample book. The simplest is just to provide the title and author like we do in our app. And this will default to a start day of today, the status of on shelf, but the other dates will be those date.distantpast, the rating will be an optional nil, and the summary will simply be an empty string. But in order to verify our UI, we need lots of other information when we view the edit screen. So if I want to test this out, I want to have some variety in our list. Now the trickiest is providing dates. So what I'd like to do is to create two more static properties, one for last week and one for last month. So I can use the calendar.current.date method, which allows me to add, using by adding to a specific date component like day, a value of -7 to the current date, which is date.now. That'll give me last week. So similarly, I can create a static property for last month by changing that date component to month and the value to -1. So you can create a lot of dates relative to the current date that you can use in your sample data. So with these static properties, I could create a variety of different books. So for example, I could have had a book that was added last month, started last week, and completed today. Now, if you don't want to create your own data, you can use the data that I provided in this gist. You can simply get to the raw value if you like, and copy all this content and paste it into the array of your sample books. Well, now that we have some sample data, let's see how we can use it. Now that we have some preview data, we can set up a memory container that we can populate with this data and use in our previews. So in the preview content folder, I'm going to create a new file and call it preview container. First, let me import SwiftData. And then I'm going to create a new struct called preview. And I'm going to create a single property that will be a container. And we're going to create it just as we created our persistent container. So I'll need an initializer. So we'll create a model configuration called config and specify that this is stored in memory only as true. There's no need to specify a URL as we did for our persisted store because it's going to be in memory. With the initializer, we can create that container within a do-catch block. Remember, it throws by trying to create the model container for book.self with that particular config, just as we did before. But now let's create a function that will allow us to add examples from an array of these type. Well, I do have these type. I do have that array of sample books. So within that function, we can loop through this array of examples with a for each loop, and then use the container's main context to insert that example iteration. Remember, we found that the container has a context, and this is its main context, and you can see here that the main context is giving us a warning that the main context is used in a context that doesn't support concurrency. And then the next warning is telling us that this must be executed on the main thread. So we create a task unit of work for the asynchronous task, and then we use a @main_actor in to have it performed on the main thread. So how can we use this? Well, let's return to our book list view then, where we use the model container for book.self_in_memory set to true. Well, we're going to replace this with our new container and examples. So first, we'll create a new instance of our preview struct. We'll just call it preview. And then we'll call the addExamples function to pass in the book sample books array as that array. So now our preview container is going to have all of those examples. But then we'll need to change the model context from using for to simply use the preview.container property as we did for our persisted container. And now, because we no longer have a single line being returned here, we'll need to specify a return on the book list view. And there you have it. Our sample books are in memory and being displayed in our preview. Now remember, in Edit Book View, we commented out the preview in Edit Book View. So now we'll uncomment it, and I'm going to create our own preview container and add in our books just as we did before, but we don't need to add in an array. What we can do is simply create a new preview object that has this container, and then as before, apply the model container for that preview container. Well, now we'll need to add a return for the entire navigation stack, but the Edit Book View requires a book, so we can pass in any one of our books from the sample books array. So for example, item 3, and we see that that is now displayed in our preview. And having an array of sample books, I can change that index to display a different book. Well, this is displaying our book okay, but we wouldn't be able to make any modifications in the preview here unless we specify that model container method passing in our previews container. Well, this is pretty good, but we can do one better than this because eventually we might be adding in more models, and I don't want to have to create a different preview container type struct just to display those different objects. And I might even want to reuse this preview container for different projects. Right now, all we're reviewing is this book model. If we return to the preview struct, everywhere I see book, I want to replace this with something that I inject when I initialize this preview. So this is going to have to happen in the initializer. So rather than injecting just a book, I'm going to inject models, and it's going to be a variadic array of persistent model.type. So I can pass in more than just book. I can simply pass in every single model that I want. Well, now the problem is that my constructor for the model container can't pass in a type any persistent model.type as variadic arguments. Fortunately, though, our container has another constructor, as we've learned, and that's the one that allows us to add a schema. And a schema can take a variadic set of models. So I can let schema equal schema models. Well, then we can change our model container to use the schema instead. And then finally, where we have that function to add our examples, well, this doesn't have to be an array of books. It can be an array of any persistent model. And I can call this function for any model that I pass in and their sample array. So everywhere we went and constructed our preview with our in-memory preview then, we're going to have to pass in some variadic set of models. Well, we only have one, so we'll let the preview be the preview of book.self. And we'll do that in both of our views. So first in the book list view, we'll pass in our model, which is the book.self. And similarly in the edit book view. And we make sure that we apply the model container function for that preview container. Now our previews are loaded in memory, and I can perform all the same actions that I do when I run on the simulator. Now, if you're interested in learning more about these previews, I suggest you watch a video created by TundsDev on working with previews in SwiftData. He has a very nice solution for streamlining the previews even more, but I'm going to leave it like this, as I think it might help you understand containers, contexts, and configurations and schemas a little bit better as you're learning, but definitely worth a watch. In the next video in this series, we're going to start to take a look at how we can filter and sort our list of books. And this is going to have to be a dynamic sort, allowing us to make those changes on the fly and have the view refreshed.